Okay, guys, hello again, and welcome to the Tribune stage and Constantine 7. I have that honor to introduce you to the tech experts here. And first topic is, like you can see, from Docker'fail to Dockerfile. I hope this is correct because I'm just a marketing manager, not a developer. Something a little about Mohammed. Mohammed is a community catalyst, and he works at Spotify, and he is a backend engineer. Okay, I'm correct. So welcome, Mohammed, and thank you for attending this conference as a speaker.
Thank you very much. You nailed it. It's actually from Dockerfail to Dockerfile. So basically this presentation is going to about the mistake that I have personally made, and a lot of my colleagues did as well, throughout using containers and deploying applications into production using containers as well. Skipping the boring part, already done, but Mohammed, Twitter handle is Laytoon. If you want to discuss anything related to Java, containers, and everything in between, please feel free. And in this presentation, and in the next 40 minutes or so, we're going to discuss 10 pitfalls, mistakes, things that we can improve. And it's going to follow basically the cloud native or Docker ways, like the 3 phases or 3 blocks of building things, shipping them, and the demos is going to be pretty much agnostic. It's going to be using mostly Docker as a technology that was intentional in purpose, but pretty much the examples that I will give are technology agnostic, container orchestration agnostic. The principles here can apply to whatever technology you are using in the cloud native world. There are some tools that can make your life a lot more easier, but I went the hard way or the simple way. So going to be mostly Docker technologies with bash scripting. I used to bash script to highlight some of the things that we can achieve and implement some of the functionalities, but the same things that are applied in bash script can be implemented whatever your CI/CD tools, GitHub Actions, Jenkins, whatever. And there are tools that can make your life a lot more easier than using, obviously, implementing it by hand. But it works everywhere, and that was the intention. It's basically, you can take whatever concepts and principles that I'm going to highlight in this presentation and apply them to whatever technology you are going to have. And in this presentation, I'm going to highlight the story and any resemblance between what I'm going to tell here and real life is pure coincidence. And so a few months away, the manager came in with a new project, and we were all happy that we can start a new greenfield project, that we don't gonna have to deal with this legacy technology. We're gonna pick our own tools. We're gonna pick our own languages. We're gonna pick the cool stuff and be the cool kids, and implement the stuff that we hear about a lot in blogs, conferences, podcasts, and everyone is talking about in Reddit and Hacker News. So the application is basically, let me move to the code. This application is basically a wordsmith, or it's building an application that selects some words from a database and show them into in a website, basically. Let me go here. This is basically the application. So whenever you refresh the page, you will get some blocks and some Lego stuff containing basically words, and each word deployed in its own node. And it follows a 3-tier architecture. We would have a database, which is here, basically containing scripts of the words that we want to show. There is also a backend, which is a Java application, basically a simple single class file Java application that have a couple of endpoints. And then a web application used Go to serve static content. So this is basically the structure of my application. go into the slides. I have a lot of windows open. Sorry for that. So we managed to build that application. We have a code up and running, and then we wanted to use containers because everyone is using containers in the industry nowadays, and use Kubernetes, whatever you are wanted to use to deploy your application. And we managed to build a Dockerfile. And the problem with containers is whatever you put into the Dockerfile, it's going to be working, right? So this is my super gigantic Dockerfile where I have everything, basically the database, the web application, the backend application deployed into a container. And you can see here that my application is actually up and running as we speak now. The application is deployed, have 3 ports exposed, one for the database, one for the backend, one for the front end. And it's actually working. And you can serve content from there. Let's not talk about the size, because the size of my application is very small. Only almost 2 gigs, 160. So by container standards, that is a little bit big, but nevertheless, it's still working. I deployed it. The managers are happy. And we let the application run for a couple of days, weeks. And then we started to stumble upon different issues. And the first one is basically coding the developer experience, or the Code-like experience. So whatever you're going to, like, we are developers, and when we are familiar with the tools that are most native, we want to do things at a lightning speed, at a fast level, deploy things very fast. And that developer experience is slightly different when we move to containers. And we need to follow certain structures. However, we are not experts on the infra level or container level. Developers need to focus on adding new features, fixing bugs on the languages that they work with the most, and the languages they master, right? However, containers added a new layer of abstraction and a new layer of things that we need to worry about and care about and master as well. And Dockerfile is one of those things. And we need to know the best practice of Dockerfile, how we should write a Dockerfile. And this adds a little bit of friction and frustration to the developers. So this is the first file I have. And I forgot to mention that I have the bash script that I promised in the beginning. And it basically contains the steps, the build phase, the ship phase, and the run phase. I'm going to expand this bash script basically throughout the presentation. But as I mentioned, there are a lot of concepts around containers. And one of those concepts is the principles of layers and caching. Everything in containers is basically built on layers, and one layer on top of the other. And that's basically to improve the speed of building the container, leverage the cache, and improve the size of the final artifact in your container. However, to keep all that in mind is a lot for the developers. Like, we need to know the things, know our tools from a developer point of view, from a language that we use a lot point of view, and also from this infrastructure things that we are now having, containers and all the cloud-native ecosystem. Luckily, there are a lot of tools that can help us being an expert without the need of knowing all the stuff, and such tools as basically Aboullaite. So what Aboullaite offers is, I'm going to run it in a minute, what is called previous. Aboullaite is basically a tool that scans your Docker file and enables to detect the things that you can improve, the bad practices that you are implementing, and you can take those recommendations and implement them into your own Docker file. So that's exactly what I'm going to do here. So I'm going basically to run Aboullaite. OK. Did I miss something? Nope. No, it's in the base, sorry. I need to switch the directory. OK. Yep. So it's basically go to my Dockerfile, inspect it. Oh, I need to disable Docker content trust. That's a lot to handle. Anyway, bear with me here. Docker content trust should be somewhere in here. What is called? No, scan. Yes, this one. Docker content trust 0. Yes. Sorry for that. Hello. Hello. Gosh, no, not this one. Wrong key. Here you go. 0. Now I can run Docker. Okay, finally, Aboullaite. This is what it basically it outputs the things that I want to improve or I can improve. Things like pin versions on the packages that you want to install in your container. Combine the run instructions if they are related, and avoid having multiple copies, and so on and so forth. And I have a second Dockerfile, which is right next to the first one. Sorry, not this one. Should be here. Yes, where I can apply the same thing and run Aboullaite as well, where I have implemented all the things that Aboullaite suggested, and you can see it has no recommendations to have. And the difference between this first Dockerfile and this one is basically whatever Aboullaite has recommended to me, like spinning the versions, combining the run comments, and so on and so forth. So that's basically to say that we don't need necessarily to be an expert and know all the things on the Docker world or on containers world. That there are tools that can help us to do so. And from coding, like my laptop experience, there is a lot of tools, such as Aboullaite. And the good thing is those can be combined with your Git hooks. Like you can put a Git hook commit that basically analyzes and run Aboullaite and prevents the developers, whoever on your team, to push those changes into your repository, making sure that whatever lands in the repository is actually respecting the best practices. And the good thing about those tools, such as Aboullaite, is they are customizable. You can tweak them. You can be more forgiving for some tools and add them as info level and error out on another levels. That depends on the policy that you want to put in your with your team. The second thing is containers are very permissive, meaning that whatever you put inside that container, it's going to work. Like the same thing that we have. Like we grab the internet, whatever is there, and we put that into our container. The problem with that is there are no guarantees that the things that we want to be in that container will be there. And the only way to do so, up until recently at least, was to spin up that container and check things. Or you won't know it until it's on the runtime phase. However, we want to do that earlier in the phase. The earlier we can detect the bugs, the better. And that's the mantra from the industry from 20 years back. I wanted to highlight for this one another tool, which is from Google this time, which is Container Structure Test. So Container Structure Test is an open source project from Google Cloud. And what they do is basically they spin up an instance of your container, the image that you want, that you just built, and you can have a test file, a YAML test file like this one, and you can assert all the things that you want to be there for the runtime, and make sure that the image that you built is actually certified and verified and contains the things that you want to have. Things like you can check the existence of the Java binary, for example, that is necessary for running my Java backend. Check that the static file is there, where our static files and HTML, CSS, and JavaScript are there. Dispatcher, which is the Go binary. You can check files that are there. You can do a lot of things. You can even check the SSH binary or executable or package that is there. So there are a lot of things that you can do actually to achieve that. And the good thing is it can be automated with your CI/CD pipeline. So we no longer need to do manual work, but you can combine it with your package or your CI/CD pipeline and make sure that whatever you want on the final image to be, it's actually there. And it's the good thing about it, it also supports tests. Like you can run tests for your Java application, for your Go application, that is also supported to run with your Docker container, what is it called? Container test something, container structure test. To run it, basically, I need to switch the directory again. Hope it's the correct one this time, right? Probably this time I'm just going to run my script. And in the script, a lot of steps, building the Dockerfile, Docker ignore, blah, blah, blah. And you can see here that I'm running my tests. So what it's going to do is going to load my image and then run all the steps that I mentioned, making sure that the Java file is there, making sure that all the directories and the files that I mentioned, and making sure that SSHD is there. And then if something breaks, it basically would fail. So that would give you an early sign if the Docker image that you newly generated is not compatible with the things that you want to have. Hello? Any signs? OK, it's passed. So that's good. No, I'm not going to push. Thank you. That's pretty much it. It's a very cool tool enabling us to making sure that the things that we want to have is actually there. And you can be creative. You can do whatever you want with it, basically, like making sure that unwanted packages are not there. That's something you can have as well. Making sure that a certain version is there. For example, the log4j vulnerability, you can make sure that a certain package is actually on a no less than a certain version from a security perspective. That is really important. And also, you can combine it with Git hooks, making sure that it's run before it lands into the Git repository. And also, you can combine it with your CI/CD pipeline, giving you an early assessment or early feedback about how your image is basically looking. OK, moving on. The last step in the build phase is ignoring the cache and the layers and caching principle of Dockers. Now, I mentioned that briefly in the beginning. And it basically means that structuring our images needs to be on a certain way. Everything in Docker is, as I mentioned, is layers. And each layer contains some set of files and some metadata. And the more layers you have, generally, the bigger the size of your image would be. And the long it's going to take to build your image, that's a frequent source of frustration for developers waiting for the image to build, and longer it takes to send the image or push it and pull it back in case of deployment. So there are a lot of issues with that. So there's no silver bullet for that one, except from reorganizing your files from the less, or the way you import the image into your Docker file from the less frequently changed one to the most frequently changed one. And that means that you want to put the files that are less likely to change, like the OS dependencies and the packages that you grab from the internet first, and then put your code last, because you are more likely to change your code while you are developing, while you are building your application, rather than other dependencies, especially if you are specified versions for your dependencies that you are grabbing from the internet. And then that would help us to speed up the build process of your application, because you are leveraging the size of, or the caching principle from Docker. Like an example of this is, imagine that we move this layer basically here, or not, yeah, maybe here. So what would happen is, whenever we change our Go application, our Go code, the layer that is executing the Go build would basically be new. And that means that all the layers that come afterward needs to be re-executed. And that will take a lot of time. However, if we keep it that way, that means we download all the dependencies one, which is something that we don't do frequently. And it will stay there, and it will be cached for all the subsequent and afterwards runs. And then keeping our code, the code that we most likely change all the time, in the last layers. So that means that whenever you have a code change, only 2 or 3 layers are going to change rather than changing your whole build, which would help us to speed up the build process. And this is the TLDR of it, basically. Another thing is the packages. We tend to download the internet all the time. That's probably from a security point of view not good, but it's very convenient for the developers. So there is a trade-off to take into consideration here. And if your builds take minutes, or at least 1 minute, there is a lot of improvement that you can do there. Building Docker images, especially for subsequent runs, shouldn't take more than a couple of seconds. Maybe I'm exaggerating, but no more than seconds rather than minutes. And as a general rule of thumb, as I mentioned, put probably the things that you download from the internet. I would have pinned version first, your OS packages, your system packages, and then the Maven dependencies, whatever your application dependencies would need. And then your code should be last, because that's the thing that changes the most. OK, almost there, one down. So we covered a little bit about the things that bothers us from the build phase. Now we're entering the ship it phase. Or, yeah, ship it phase. And the first one is the production-like misunderstanding. And that means that in the cloud-native era and the 12 factor manifesto, it was mentioned that we should have ISO production artifact, meaning that the artifact that we generated should be deployed on all the instances that we have: dev, tests, and production. The problem is we have other dependencies that rely on those artifacts. We have databases, we have mail servers, we have other things that rely on that. And we, especially in the test and dev servers, want to have some debugging tools, some debugging information in our application or in our production that we don't want to have in production. So it makes it hard, basically, to have this ISO production artifact. However, with Docker, our containers, it's possible to achieve such thing using multi-stage build. And multi-stage is basically a feature introduced years ago in Docker, and it enables you to separate your build stage or stages from your production stage, keeping your production stage clean without the unnecessary build tools. And then you can have as many stages as you want. Like I split this old one, like it was one single stage, everything in there, into at least 2. And I separated them into the build phase, and this one here is production phase or production stage. And what I do here is basically I downloaded all the dependencies that I need. I built my Go application. I generated my jar from my Java application. And then on my production image, I basically copied whatever was generated in the build image into my production image using the from. So I've copied the app and my Go application, and then, yeah, the script to populate the database, basically. So the size of this image, of my production image, will be a lot more slimmer than my original image. And we can actually see it here. Sorry for that. It's Docker, images. Then you should grep. What step is this? 4, right? No. Something. Remember that we had almost 1.6 megabytes. Now we are down to almost 600, which is like we saved 1 gigabyte. So this is a nice side effect from using multi-stage build. And that's to say that you can have as many stages as you want. You can have like another stage for your dev server, which can contain some important debugging information tools, one for the QA, one for the test. A bad practice that we had previously in the industry is having multiple Dockerfiles in that manner, like Dockerfile.production. And we have as many Dockerfile as environments as we have, and thus we needed to maintain a lot of Dockerfiles. If there is a security vulnerability, we need to update them all, and it's kind of a bad practice that no longer should be implemented. Having a single Dockerfile with multi-stage builds, and you can specify what stage you want to invoke from your Docker run command or whatever your build tool is. Yeah, this is basically what I mentioned, and then including hacks, like if it's a div flag or introduce an environment variable, do this, if this, do that. There's no need to have those hacks anymore, leveraging the multi-stage build with env profiles and have specific values for the different environment that you have and you want to deploy your artifacts to. Okay, moving on, halfway through. Secrets. And then secrets is a really important matter in software engineering in general, and especially when using containers. Up until step 4, you can see here that I was, what is it? Here. No, it's here. I was basically, don't know if you noticed, but I was including the Postgres password secrets in clear text. That is something to not do in production at all. And the reason is, it's once you push that into your Git repository, it's going to be on the internet. Another thing to not do is to include the secrets into your Dockerfile. Don't know if I mentioned it before, but the layers in the Dockerfile are not immutable, meaning that if you change it, if you included something in previous layer and then try to delete it afterward, is not actually a delete, because like that layer will still contain the information that you introduced. So that is something important to keep in mind, to not include anything sensitive in your Docker images and any of the layers, basically. Some tools that I want to highlight in the secrets part are two things. The first one is the G-Shield. So G-Shield is an open source tool that basically scan your image. So it export your image, distract it into multiple layers, and scan all the layers, and making sure that it doesn't contain any secret or format. The second thing is, instead of hard coding the values of your secrets, using a built-in tool available in all container orchestration tools, such as in Docker, we have Docker secrets. You can create your secret and basically mount them into your running container. It's going to appear as environment variables, and you can use them basically whenever you want. And you can have like per environment secret that you can use, and that's why you are saving them in a standard information, following the best practices, rather than like leaking them by mistake to the internet. Maybe we can have a quick look at, is it step 5, right? The secrets, and then if I run the build, run, ship run, it's going to do a lot of things. Yeah, the test is going to take some time again, but it's going to run G-Shield, and you can see afterward that it's basically take our image, decompose it into the multiple layers, and check all the layers. You would need G-Shield is free, and you would need an API for it. It's basically free. That runs the tests, and it have multiple G-Shield, right? It have multiple goals or targets. So it can scan your Docker images, or it can scan your Git repository, or it can scan other things. So it's not specific to containers, but it can scan even your code against leaking secrets. And you can see here that is decomposing my image and then scanning it basically to check if there are any secrets there. And then when the scan is done, you have a result, either a failure or a success. Here we found like there are no secrets found, so our build passed and moved to the next steps. Thank you. Don't want to run my applications. And we are human. Mistake happens. So better to avoid leaking those passwords and having a prevention tool to give you the heads up and the nudge before pushing intentionally those secrets to the internet. And as I mentioned, G-Shield is open source, and you can combine it with your CI/CD tool that's basically fail if it found a secret, and it will enable you to avoid leaking those secrets both, in your code or in your container image. The last one in the ship phase is tags. And tags are a very important topic in software engineering in general. Like tagging your version is, or tagging your artifacts is important, as it enables you to deploy specific version, roll back, and so on and so forth. And it is more important in the containers world, especially that Docker has no enforcement in making the tags immutable. You can override the tags of your image as much as you want. And unless you have it, or unless you enforce it in your container repository, it would basically not force it as well. And the problem with that is if you have a version that is deployed in your cluster, rolling back can be really hard if you have like similar versions. Let's say you're deployed with 1.0, you override that version that contains a hotfix. You want to deploy it, your container orchestration might have a hard time to detect it. Now, luckily in Kubernetes, they solved that issue by using digest to detect what image needs to be deployed, but still in some other orchestration tools, it would be problematic. So keep in mind that tags are not immutable in the Docker world. Another thing, so we can see here that I move it from specifying the, I don't know what I was using before. Okay, sorry for that. I was using prod for tagging all my images, and up until step 5, I was overriding all of them. However, here now I'm using basically date, which is like not a good option, but still, it gives me a one-to-one mapping to the changes that I've made. And it's really important in software engineering world to have, for each change you made, specific version. And you can use whatever you want, either a git hash commit or a symvec version, as far as is identifiable and unique, basically. Another thing that I wanted to mention is sbom. This is an experimental Docker command, and sbom stands for, oh, God help me here. I blanked out, is bills of material, but what the S is. No, software bill of materials. Thank you. So software bill of materials. I was like going to say a synthetic bill of materials. It's like it doesn't make any sense. No, I tried to make it up, but yeah, exactly. It's like nah. So software bill of materials, and this is widely known in the security world. They always have a software bill of material that is basically a scan of whatever running in production into a text file, something like this, basically. And this flag or this command from Docker, it basically does the same thing. It prints out all the running executables, packages of your inside your container, and it gives you an overview of what is running, what you have, what applications are running, and what version they are in. And from a security point of view, this is a great win, because if there is a vulnerability on one of the packages, and when there is a alarm fire, everyone is running out, everyone is panicking to understand if we are actually building our application in this outdated version or vulnerable version or not. This can be actually a good one to give you an indication if you're running on a vulnerable version. And it's can easily be combined with other tools to give you not just notifications. If there are any vulnerabilities that are found in the internet, it can use that to give you awareness or raise awareness about the importance of updating your dependencies, or if you need actually to update your dependencies. Okay, so I was here. So basically, yeah, it's basically generate this plain text file that you can use using like save it in a Git repo and do whatever necessary. Combine it with other analysis tool that give you an indication of what software are you running, and you'll be surprised on how much software you weren't aware of that you are running an application. I've read like later that few days back that now almost 90% of the code that we are on in production are not the code that we maintain and we own and we code. So that's a little bit scary, which raises the concern around security and such. But nevertheless, using Docker SBOM is an experimental feature. There are other tools that offer the same thing as well, but it's a good idea to give you an indication of whatever you are running inside that container and probably remove even the things that you don't need. Using Git repository to have versioning of your software bill of materials and also combine it with other tools that does analysis and having one-to-one relationship between the changes that you made and the version of your artifacts and Docker images helps you to avoid some weird behaviors of your container orchestration tool. And yeah, as I mentioned before, some Docker registries, most of them doesn't enforce image overriding or image version overriding. You can disable that and enforce the usage of specific version for each new image or code change. That sums it up for the ship phase. Now we're going to the fun part, which is the run phase, running things into production. We're running a little bit out of time, so I'm going to speed it up. The first thing is adding health checks. Now, health checks is an important thing to have when running application in production, especially of application that suffers from slow start. We heard a lot in the Java world that it has a slow start. Things can improve it a lot with Java 17, but still, it's still a slow start compared to other languages. And if you have a legacy application that takes a lot of time to start, adding a health check is really important. However, be really cautious about shooting yourself in the foot. Like overusing the health check can bring your application into its knees, basically. There is no silver bullet, no golden rule here. You need to watch your application, monitor it, and tweak your numbers to have good numbers that are not too permissive and too forgiving and not too pessimistic, basically, that can turn your application into an infinite restart policy. So for my Docker, for our application, what we did basically is we added the health check that is available in Dockerfile, but it requires Docker Swarm for transparency here. But there are available things in Kubernetes as well. In Kubernetes, there are more things. So readiness probe to make sure that your application is basically ready to serve traffic. You need to have good numbers about when your application is ready and when to start hitting that health check to serve traffic, especially when you don't want to have any downtime while deploying. Liveness probes, where your container is live and is basically live and ready to spin things up. Kubernetes version 1.19 add in startup probe, and it is specifically designed for legacy applications that takes a lot of time to start. So it's added this basically for slow start application to not bombard your container with health check requests and something that can kill your application. And as I mentioned, there is no golden rule. You need to have data-driven approach here and data-driven metrics that you can add to adjust your liveness probe and the health checks. Multiple processes, and that is basically coming in the old days of containers where we had this comparison between VMs and containers, and we ended up throwing everything in one Dockerfile, as I did. So thanks for being with me this whole application. Now I'm splitting the application into three different components, which is the things that we would do basically in any distributed and microservice architecture. So what we did here is basically splitting this monolith Dockerfile that I had into three ones and adding a Dockerfile of each component basically. So now I have a dedicated container or dedicated image for my backend application, another one for my front-end application, another one for my database. And then I'm deploying them using Docker Compose, because for convenience, as I mentioned in the beginning. But yeah, you can use those generated images, you can deploy them on whatever your orchestration tools you are more comfortable with. And yeah, so building them here, the scripts become a little bit more verbose, but that's obvious. We struggle a little bit in the building phase, but we gain in the run phase. The architecture is becoming more structured and more less coupled. And then, yeah, I'm using Docker Swarm to deploy my application, and yeah, combining everything that I had earlier. Yeah, basically splitting the application into scoped services, allowing you to have less coupling between those, especially if you are in a single Docker file. Having a Docker file per service to improve the size of your images. Basically, they will be a lot more smaller and single focused and single processed. And yeah, having a proper orchestration, combining it with Customize and Helm, which is basically more of a templating tools in the Kubernetes world, enable you to add variables, and depending on your environment, define which variables you can use. Those need a session on their own, but please feel free to check them after the session. And then finally, security as a second thought. And security needs also a session on its own, but there are a couple of things that we can basically implement, enabling us to ensure the security of our images, starting with scanning your images. Luckily, Docker introduced freely what we call Docker scan, which is a combination with Snyk, which is a startup. Still a startup? Not sure. Yeah, still a startup. But it's specialized into the DevSecOps world. It scans your artifacts. And they had this core partnership with Docker, which Docker scan under the hood sends the information to Snyk, which scan your image and then give you indication about vulnerable software that you're running inside your container. So scan your image, and having strict rules in case you have critical vulnerabilities there, and stopping deploying the images is something that you can include in your CI/CD pipeline. Also, using Docker Content Trust. And Docker Content Trust is a signing tool, basically, or using a signing tool, not necessarily Docker Content Trust, but a signing tool that when you push the image, it will basically sign your image with your private key. And you want to pull the image back, it will verify that during deployment that the image that you pull is actually signed. So no unsigned image will be deployed. The source only signed images, which adds another layer of security that only the images that are trusted, in a sense that are signed, are deployed. And for that, that was I was enabled Docker Content Trust in the beginning for exactly that, but I can do a quick demo. Okay. So I'm enabling it, going basically to push an image, and you're going to see that it's going to ask me afterwards to add a key or a passphrase for it. I hope that's right. And then it's basically push it. And that's basically, it's push the image and then sign it with some metadata. And the metadata it signs, it's you can check it using the Docker Trust Inspect command. And as you can see the information about how the image was signed, who signed it, the digest of the image that was signed, and so on. And then when you want to deploy it afterward, the Docker runtime, basically, or any container runtime will talk to the signing entity, in my case, Docker Content Trust, to verify that the image that is signed is actually the image that we want to deploy. No signed image will be deployed, basically. No unsigned image will be deployed. That was worth clarifying. The TLDR, scanning your images, really important from a security point of view. If you don't need kernel capabilities or root capabilities, make sure to run your containers with read-only. And as a general rule of thumb, following the least privilege principle, making sure that your application and your container is running with the minimum set of access rights and resources, enabling it to perform its function. And leveraging some functionalities of container runtime, such as using namespaces instead of root daemon and such. Okay, that's sum it up for the 3 phases. And I want to end up with one thing, and the last one is you don't probably need a Dockerfile. Now, that is hard to say after almost 40 minutes of exploring Dockerfile, but the ecosystem has a lot evolved since the invention of containers. And we have now more built tools to build our container image with. And one specific tool that I want to demo here is called Jib. And Jib, if you're a Java developer, it's basically a Maven and Gradle plugin available in both that enable you to build container images without the need of worrying about Docker at all. All what you need to do is to add the plugin here, Jib Maven plugin, and then build your image using, if I'm not mistaken, this one. So I'm running, nope. So what I'm doing here is compiling my Java application and then invoking Jib to build my application or my container image. You can see here like Jib is extracting my application and then pushing it to the container registry. So you can use Jib without the need of having Docker at all in your containers in your runtime, which is a good thing from using the same tool that you are familiar with as Java developers without the need to worry about Docker as a new thing. But there are a lot of tools that you can use right there. And while making the slides, like the slides couldn't fit. Like I can have a book around the things that we can use to build our container images. But that's pretty much it. 10 things that hopefully would make working with Dockerfiles a little bit more enjoyable and a little bit more safe. Ready to take your questions, and thank you. Any questions? That was either super clear or I messed it up. Going once, going twice.
Okay, what's your favorite build tool?
Jib, definitely, Java developer. I added a whole slide. Like, I used to give this presentation with Jalal, and we have this heated debate about Jib doesn't fit into the presentation. I said, no, we need to add this dedicated slide for it. So. Okay, thank you. The stage is yours now.
I have a small break.
Okay. Sure, tell me.
Okay.
Links, I mean, it's unusable when I make a photo. It would be great that you put URLs.
Put my what?
URLs.
Oh, okay. True. Yes. Yeah, I'm going to share the presentation afterward on Twitter, but you're right. Okay, I will. Okay, you're right. How about that? Hot fix. Okay, now you can take a picture. Here you go.
Yeah, but if you get the slides, you'd also get the other things.
Yeah.
So.
Okay. How about now? Okay. Cool.
We can have a small break if you need it, or if you don't, you can just stay here and we can start.